All right, this section is 2-3, which is rate of change and slope. You should remember a lot of this from Algebra 1. It's okay if you don't. I'll slow down and take my time and show it to you, but I'm hoping you remember a lot of it. So rate of change is also your slope. It's the same. So rate of change is the ratio, which is a fraction, that compares how much one quantity changes on average relative to the change in another quantity. So you have delta y over delta x, which means change in y over change in x. So before, you probably used these formulas down here, where slope, which we call m, is y2 minus y1 over x2 minus x1, or also rise over run, or delta y over delta x. So let's pause here for just a moment. When you have two ordered pairs, x, y, and we'll call that x2, y2, you can call this one x1, y1, and you can call this one x2, y2. It doesn't matter which one as long as you're consistent. So the change in the y's go on the numerator, and the change in the x goes in the denominator. When you're talking about rise over run, rise is up and down. That makes sense, right? Rise, you can go up, you can go down. If you go up, what is it? Positive or negative? It's positive. If you go down, that's obviously negative. When you run, unless you're super cool, you probably run horizontally, right? I can't run up walls. So when you run, it's horizontal. It's left and right. If you go right, is it positive or negative? Positive. When you go left, negative. So rise is up and down. Up is positive, down is negative. Run is left and right. Right is positive, left is negative. And we'll talk about that when we have some examples later. So when we have our slope-intercept formula, which is y equals mx plus b, m is your slope. B is your y-intercept, but I don't think we've really worked on that today, so don't worry about that right now. Another few things that I want you to add to these notes is when you have 0 over a number, because that may happen, you could use your calculator if you want to, but is that 0 or is that undefined? 0 over anything is 0. When you have a number over 0, what's that? That's undefined, okay? When you have 0 under, it's undefined. So if you ever forget that, take your calculator out really quickly and just take, I don't know, 0 divided by 12. And what do you get? Well, that's 0, right? 0 divided by 12 would be 0. Now take 12 divided by 0. And you get error, or you get syntax error, or your calculator blows up or something, right? So that means it's undefined. So if you ever forget, you could always use your calculator, but it's probably best if you know it. So one more thing before we actually get going with the notes is some people kind of forget what our lines look like. So if this is my xy coordinate system, here's x, here's y, okay? If I have a line like this, is that x equals a number, or is that y equals a number? This is x equals a number. This is like x equals 2 or something. So is this slope undefined, or is it 0? Do you remember? Up and down, undefined. Up and down, undefined. So our slope would be undefined here. If I draw something here, this is y equals something. So like y equals 2 or something like that. And then this slope would be 0. So it's just kind of nice to know those quickly and easily and have those ready to go. You could always do the math if you really had to, but it's nice if you know it. All right, let's get started on the notes. Find the rate of change for the set of data. So the time in days and the height in millimeters. So you have some data points here that you could put as an ordered pair if you'd like to. So typically with something like this, I just choose 2 ordered pairs and I do my slope formula from there. I don't feel like this would be very easy to count, so I'm just going to pick ordered pairs. So I'm going to do 3, 20, and I'm going to do 6, 40. Okay? I'm going to plug it into my slope formula, where this is x1, y1, this is x2, y2. So your slope formula is going to be y2, which is your 40, minus y1, which is 20, over x2, which is 6, minus x1, which is 3. So what is 40 minus 20? It's 20. 6 minus 3 is 3. Does that reduce? No, it doesn't. So you could leave it as 20 over 3 if you want to, but because this is kind of like a story problem, it's a real world example, I'm going to go ahead and change that to a mixed fraction. I'm going to say that that's the same as 6 2/3, and that would be millimeters per day. Okay? That one's done. The next one, find the slope. So again, you can do it any way you want to, but if they give you ordered pairs, I typically stick with my slope formula, the y2 minus y1 over x2 minus x1 from up here. If they give me a graph and I can count, I typically do that instead. It's just up to you. So let's go ahead and plug this in. So m is equal to y2, which is 3 for me, minus y1, which is negative 11, over x2, which is 6, minus x1, which is negative 9. If you really wanted to, and you wanted to call this x2, y2, and x1, y1, you can. You're going to get the same answer either way, but I typically call the first one x1 and the first one y1, x2, y2. So what's 3 minus negative 11? Two negatives make a positive. We get 14. And 6 minus negative 9, two negatives make a positive. We get 15. So it's 14 over 15. Does that reduce? Nope. So we're good. 14 over 15, we're done. Why don't you try this one on your own and see if you get it right? So on this one, you're going to take 4 minus 4 over negative 2 minus 5. Well, 4 minus 4 is obviously 0, and negative 2 minus 5 is negative 7. But 0 over anything is just 0. If you're not sure, use your calculator. It'll give you the same answer. Determine the rate of change for number 19. So again, if this was on a graph, like graph paper, I think it's really easy to count. But for me, this is kind of hard to count, especially because it doesn't go by ones. I'm afraid I'll forget that that went by, it looks like, fives. So instead, I'm going to go ahead and write two ordered pairs and use my slope formula. So I'm going to start with, it looks like that's 0, 5. I'll use that as one of my ordered pairs. And you can pick any other ordered pair you want. The other one that was really easy for me to tell was the 3, 20. The other ones I wasn't quite sure I was going to get right. I thought maybe there was like a half in there or something. So I just used 3, 20. So you plug it into your slope formula. So if you really need it, this is x1, y1. This is x2, y2. So your formula is y2 minus y1 over x2 minus x1. Write that until you have it memorized. Once you have it memorized, just go ahead and plug and chug. So we're going to have 20 minus 5 over 3 minus 0. Well, what is 20 minus 5? 15 over 3, and that for sure reduces, which gives us 5. So number 19 is just a 5. On number 25, this one looks a little bit different, right? They didn't give us any ordered pairs. If you really wanted to, you could do it that way. I always show you the easiest way for the question that's given to you, but if you really want me to show you a different method, you just let me know, okay? So I'm going to put this one in slope-intercept form. So again, slope-intercept form is y equals mx plus b, where m is your slope. So on 25, I want to get the y alone. So I'm going to go ahead and subtract 12x from both sides and subtract the 5 from both sides. So I'm left with negative 4y equals, let's do the negative 12x first, because you usually want that first anyway. And then what's 18 minus 5? Well, that's just 13. So now what's in the way of y being alone? The negative 4. What's it doing to the y? Multiplying. What do you do to undo that? Divide. What you do to one side, you do to the other side. Again, instead of one big long line, I usually put it under both pieces so I don't forget. So I'm going to go ahead and say that y is equal to, that's going to be, two negatives make a positive, 3x minus, that doesn't reduce, so I'll just leave it as 13 over 4. So again, the question was the rate of change, which is really slope. So it's just 3. Slope here is 3. All right. Number 27. Again, find the slope is what they're asking. Get y alone, put it in slope-intercept form, and then we'll go from there. So try it out. Okay. The first thing I see in the way of y is the 3/2 x. So I'm going to go ahead and subtract that from both sides. So I have negative 5/4 y equals negative 3/2 x plus 15. Now what's in the way of y being alone? the negative 5 over 4. It's multiplying by y, so you could divide both sides by negative 5 over 4 if you want to. I prefer to multiply by the reciprocal, so I'm going to multiply everything by negative 4/5. If I do that, these two make a 1. So negative 4/5 times negative 5 over 4 is just a 1y. And then again, you can use your calculator if you want to. Negative 4/5 times negative 3/2 is going to be 1 1/5 x. Or if you write 6 over 5, that's fine too. And then it's going to be a negative. And what's negative 4/5 times 15? And it's just negative 12. Okay? So here's the problem. Slope always has to be improper. Okay? You can't give me slope is 1 1/5. That's not really right. So instead, we should say the 5 times 1 is 5, plus 1 more is 6. So 6/5. So slope here is 6 over 5. Notice I don't write the x. That's not the answer to slope. Slope is what's in front of x. It's the coefficient on x. On number 33, I changed it to 10 comma r, 4 negative 3, and m is 4/3. So what that means is this time they gave me the slope and they want me to find r. So think for just a second, what on earth are you going to do? Where do we start? Okay, typically with something like this, I would have done x1, y1, x2, y2, and my slope formula, right? So let's still do that. M is equal to y2 minus y1 over x2 minus x1. When you're stuck, start with a formula. Let's fill the formula in. So this, like I said, I'm going to call it x1 and y1. I'm going to call these two x2 and y2. And m is 4/3. So instead of an m, I'm putting 4/3. I'm plugging it in, so I'm going to have negative 3 minus r over 4 minus 10. Pause there for just a second and make sure you understand how I plugged these into my formula. Okay? There's a lot of different ways you can do this problem. For right now, I'm just going to simplify as much as I can. 4/3 is fine. I can't do anything to this numerator, but I can go ahead and change 4 minus 10 to what? Negative 6, right? So 4/3 equals negative 3 minus r over negative 6. So from here, again, lots of options. I am going to go ahead and cross multiply. So when you have one fraction equal to another fraction, you can take this times this, so 4 times negative 6, and set it equal to this times this. So that said 3 times negative 3 minus r. This is just one way to do the problem. If you want more options, let me know later. So that's going to be negative 24 equals distributive property, negative 9 minus 3r. From there, you should definitely be able to finish this problem. What are you going to do next? You're going to add the 9, right? So we get, what's negative 24 plus 9? It's going to be negative 15 equals negative 3r. What's in the way of r being alone? The negative 3. What's it doing to r? Well, it's multiplying. How do we undo it? We divide. What we do on one side, we do to the other. That really does give me a 1r, which we don't write the 1. And 2 negatives make a positive. 5. So r is 5. If you wanted to and you weren't really sure if you had done this right and this was a test or a quiz or something and you had some time, you could go back and plug r in and then see if it gave you the correct slope. That would be pretty easy to do. Alright, I went ahead and added a few questions on the back of your notes. So go ahead and flip that over. So with these, I wanted you to find the slope between the 2 points. These are already graphed for you. You could go ahead and find the ordered pairs of a and b and plug it into the slope formula if you want, but I want you to get comfortable counting using rise over run. So instead, I'm going to do rise over run. You start wherever you want. If you want to start with b, fine. If you want to start with a, fine. Typically, I don't know why, but I start with the one that's farther down. So I'm going to rise and then I'm going to run. Okay? So I'm going to rise 1, 2, 3, 4, 5, 6, 7, 8. I went up 8. So it's a positive. I'm going to run 1, 2, 3. And I went to the right, so that's positive. 2 positives stay positive, and I can't reduce it. So my slope is 8 over 3. So sometimes people do this and this, or they draw themselves a triangle. That's 8, that's 3. Whatever works for you, it's fine. Let's pretend I didn't do that, right? So let's do, let me erase this. There's another way you could have done it. Typically one way is fine, but I want to make sure you get it. Okay? So you could have done from A to B. So I'm going to rise down 8 places. And I'm going to run left 3 places. So that's a negative. 2 negatives make a positive. So either way you get the same answer. No big deal. Let's try the next one. I'm going to start here this time. I don't know why. I guess I just do it differently every time. I'm going to rise. That's down 2. So negative 2. I'm going to run 1, 2, 3, 4, 5. And that was positive. So my slope is negative 2 over 5. Super easy. If you wanted to, you could have said that this was the ordered pair 0, 2, and this is the ordered pair 5, 0, and you could have done your slope formula. That's fine. We also can add a question here just really quickly if you'll watch. I'm going to pretend B isn't there. I'm going to put B in a different spot so you can see something else. Let's put B right here instead, okay? So I'm going to rise down 2 still. So negative. I'm going to run right 4. Well, what's my real answer then? Negative 1/2, right? Don't forget, you always want to reduce. If you have any questions, let me know. Make some notes on what maybe you kind of missed, and then let me know what you need.